Have you ever really stopped to think about how your computer understands everything? From a simple text message to a super complex video game? Well, it turns out it all comes down to this kind of secret language. And today we're going to decode it together. All right, let's jump right in.
So, here's what we've got on tap. We're basically going to go on this journey, starting with the absolute smallest spark of data and building all the way up to the global network that, connects all of us. First, we'll get into the computer's native language. Then we'll explore how it actually counts. And we'll even solve a really common tech mystery. And finally, we'll see how the whole thing comes together to let us talk to anyone, anywhere in the world.
You know, it's pretty wild when you actually stop and think about it, right? I mean, you send a laughing emoji, and your friend halfway across the planet sees that exact same emoji instantly. How on earth does a machine, a thing made of silicone and metal, understand something so human? Let's dig in and find out. The answer, well, it's almost ridiculously simple. At its very, very core, a computer is nothing more than a massive collection of billions and billions of tiny, tiny switches. And from that one simple idea, on or off, literally everything else we do on a computer is born. Okay, so let's zoom way, way in on one of those switches. What we're about to see is kind of like the atom of the digital world. It's the single fundamental building block for everything. So that simple on or off state, that's what we call a bit, short for binary digit. It's the absolute smallest piece of information a computer can possibly handle, and we represent it with a 1 for on and a 0 for off. It's a lot like a single pixel on your screen, right? One little dot doesn't do much by itself, but you put millions of them together, and suddenly you've got this amazing high-definition picture. A single bit is kind of useless on its own. It's like having just one letter of the alphabet. You can't really say much. So to make actual words, you need to group letters together. And in the computer world, that's exactly where the byte comes in. We take a group of 8 bits, and boom, we have a byte. And with those 8 bits, we can suddenly make 256 different combinations. That's more than enough to give a unique code to every letter, number, and punctuation mark we use. Okay, so we have bits and bytes, but nobody, and I mean nobody, wants to stare at a screen full of millions of zeros and ones. That would be an absolute nightmare. So over time, we've come up with some really clever ways to group all that binary stuff into more human-friendly chunks. You can think of it like creating shorthands or abbreviations. It's all about making it easier for us people to read and write computer code. So we humans, we live in a base 10 world, right? We use 10 digits, 0 through 9. That's just how we count. But computers, as we just learned, are all about base 2. Just 2 options, 0 and 1. To make life easier for everyone, programmers use these sort of bridge languages like octal, which is base 8, and hexadecimal, which is base 16. Why? Because they're way more compact than writing out long strings of binary, and that makes them perfect for some very specific tasks.
And this is where it all clicks into place. See, each of these systems has its own job to do. Decimal, that's our everyday language. Binary, that's for the machine. And hexadecimal, oh, that's like the cool secret language that web designers and programmers use all the time. It's just a super efficient shorthand. You see it everywhere. When you pick a color for a website, that 6-digit code, that's hex. When programmers need to tell the computer exactly where to find a piece of data, they use hex for the memory address. It's like giving the computer a very specific street address. All right, let's talk about something I'm sure you've all experienced. Have you ever bought a new hard drive and felt just a little bit cheated? You buy a brand new 1 terabyte drive, you plug it in, and your computer says you have way less than that. What is going on? Well, it all comes down to a simple case of things getting lost in translation between how marketing departments count and how computers actually count. I mean, we've all been there, right? You get that shiny new drive, you plug it in, and poof, a big chunk of that advertised storage is just gone. But I promise you, it's not a scam. It's really just a classic case of humans and computers speaking slightly different mathematical languages. Okay, so here's the secret. There are actually 2 different stories being told at the same time. On one hand, you have the marketing folks who use a simple, human-friendly system based on powers of 10. Thousands, millions, billions. But your computer? Oh, it's telling a much more precise, technical story, one that's based on powers of 2. Now this right here shows you the world from the computer's point of view.
See, for a computer, a kilo isn't a nice round 1,000. Nope. It's 2 to the power of 10, which actually comes out to 1,024. And that tiny difference of 24 bytes, it might not seem like a big deal at first, but it really starts to add up. It compounds as you go from kilobytes to megabytes to gigabytes and all the way up to terabytes. But let's be honest, from a marketing perspective, round numbers are just better. They're cleaner. Saying 1 trillion bytes sounds a lot catchier than saying, well, 1,099,511,000,000. You get the idea. It's just simpler. So the key takeaway is that you're not actually getting less storage. It's just that the way it's advertised and the way it's measured are two different things. And that explains all that missing space. Okay, so we've cracked how computers count. Now, for the next big piece of the puzzle. How do they learn to read and write? I mean, how do we take all those numbers, all those bytes of ones and zeros, and turn them into the actual words, sentences, and emojis that we use every single day? Well, that is the magic of what we call character encoding. I want you to imagine a kind of universal dictionary, a book that lets computers and humans perfectly understand each other's language. That, in a nutshell, is exactly what character encoding is. It's the Rosetta Stone for the digital age. It's a system that gives every single letter, every symbol, and, yep, every emoji its own unique number. You know, back in the early days of computing, it was basically the Wild West when it came to text. You had this system called ASCII, which was awesome if you only spoke English. And then you had these other totally separate systems from big companies like IBM that they used for their giant mainframe computers. The huge problem was none of these systems talked to each other, and that led to so much confusion, and you've probably seen it, just screens full of garbled nonsense text. This whole situation was a real mess. It was like a digital Tower of Babel. You could send a totally normal email from one country to another, and it could show up on the other end as a screen full of complete gibberish. The world was getting more connected, faster and faster, and we desperately, desperately needed a single way for all of our devices to speak the same text-based language. And as you can see here, the old systems just weren't going to cut it anymore. ASCII was fine for the English alphabet, sure, but what about all the other languages in the world? What about Cyrillic or Japanese kanji? And what about emojis? Where did they fit in? The world was becoming one big, connected network, and we needed a character system that was just as global as the internet itself. And then, along came Unicode, the real hero of our story today. Think of Unicode as that giant universal dictionary. Its job is to assign one unique number to every single character in every single language on Earth. And then you have formats like UTF-8, which are these super clever, super efficient methods for actually writing those codes down in the computer's memory. This whole system, it's the reason you can seamlessly type in different languages and use emoji on your phone without a second thought. It is truly the unsung hero of our modern connected world. And just like that, our journey has come full circle. We started with a single, simple on-off switch, one tiny spark of information. And from that, we've built this incredible system that can contain, well, pretty much the entirety of human expression. It's honestly an amazing testament to our ability to create order out of what seems like chaos, and to build these incredible bridges between our world and the world of machines. So, for more than 70 years now, our entire digital world has been built on this one, beautifully simple idea, zeros and ones. But it makes you wonder, what happens next? What happens when our computers can think beyond just on and off? I mean, with stuff like quantum computing coming up on the horizon, where these qubits can be both a 0 and a 1 at the exact same time, the next chapter in the story is literally just beginning to be written. So what do you think that next language will look like?